Okay, I'm going to show you how to solve the problem from Problem Solving Exercises 5, Exercise 9. This is the 500 kilogram pig standing at the top of a muddy hill on a rainy day. Essentially, we have to use the law of conservation of energy to solve for this. So here's how you do it. First, we're going to list our given information. Okay, first we have a mass of 500 kilograms, and then we have a 100-meter long hill with a vertical drop of 30 meters. Now, since the pig is getting all the energy from potential energy, essentially being on top of a hill, it's the vertical height that we want to look at, because gravity is not going to affect the horizontal motion. So that's pretty much it. That's all we need to do this problem. And our unknown variable is, what is the pig's speed? And then it says use the law of conservation of energy. So that's a clue on which equation we're going to use. Law of conservation of energy says that the total energy is equal to the kinetic energy plus the potential energy. So in this case, we've got the pig at the top of a hill, in which case it's got all potential energy. And then, so that's right here. And then it's going to slide down, and at the very, very bottom, that's before it stops or anything like that, it has all kinetic energy and no potential. So top of the hill, all potential, no kinetic. Bottom of the hill is all kinetic, no potential. The total amount of energy throughout is the same. So the potential energy at the top equals the kinetic energy at the bottom. These two things are equal to each other. So this is the concept of what we're going to do. Now it's asking what is the pig's speed, so we're going to pull speed from kinetic energy. So basic concept, kinetic energy at the bottom is equal to potential energy at the top. And we'll go ahead and we'll unsimplify these. We'll go ahead and expand these out. Kinetic energy is 1/2 the mass times the speed squared. Potential energy is mass times acceleration due to gravity times the height. Since we're talking about gravity, that is the vertical height. So we could say dy or hy, if you will. I don't know why it does that. So again, we're going to solve for v. We're going to solve for the speed of the pig. So we set both sides. We're going to multiply both sides by 2. End up with mv squared equals 2mgh. And divide both sides by m, and hopefully it's obvious, but I'll go ahead and write it down anyway. V is equal to the square root of 2 times acceleration due to gravity times the vertical height. So all we have to do is plug this in. Square root of 2 times 9.8 meters per second squared, and the vertical height is 30 meters. So we're going to square root all of that. And going ahead and looking at the units real quick, we have meters squared over seconds squared, because we have a meter times a meter divided by seconds squared. And if you square root this, you're going to end up with meters per second, which is the correct unit for speed. So now grab the calculator, and you end up with 2 times 30 square root of that equals 24.2 meters per second. So that's the speed of the pig going down the hill, and in this case we are assuming there's no friction. We're just not going to do one of those. Okay, hopefully this helps. Wow, this would be a great test question, wouldn't it? Have a great day.